Happy morning, friends. In today's class, we are going to see about supervisor mode, exception and traps. Why supervisor mode? Always our processor executing number of programs, complex programs. So we need to ensure the complex program is not interfacing with each other. For that, we need to provide some hardware checks to implement the additional level of safety. In such cases, it is often useful to have a supervisor mode that is provided by the CPU. So during the normal program run, it is in the user mode. So the supervisor mode has some privilege that user modes do not. For example, the memory management addresses of the memory location to be changed dynamically. So the control of the memory management unit is typically reserved for supervisor mode in order to avoid the obvious problem that could occur when the program bugs causes inadvertent changes in the memory management register. And during that time, the CPU enter into the supervisor mode. For supervisor mode, the CPU will execute SWI code 1. So here the SW causes the CPU to go to the supervisor mode and set our PC register, current PC addresses to the R14 register. Here the argument, that is code 1, is the 24-bit immediate value that is passed on to the supervisor mode code. It allows the program to request various services from the supervisor mode. So during the supervisor mode execution, the current program status register lower 5-bit is set to 1 in order to announce the CPU enter into the supervisor mode. The old value of CPSR just before the SWI code execution is stored into the saved program status register, that is SPSR. So there are the several SPSRs from the different modes. The supervisor mode SPSR is referred to as a SPSR underscore SPC. To return from the supervisor mode, the supervisor restores the PC from register R14 and restores the CPSR value from the SPSR SPC mode. So the next one is exception. Exception is internally detected error. Simple example for exception is division by 0 error. So when we are dividing any number by 0, the answer is infinite. During that time, exception is produced. So, but we must ensure our program should not contain any exception error, like the program should not contain any division by 0 error. But it is not possible to check every line of the instruction of the program because it will substantially increase the program number of lines in the program as well as the cost in the program. So the CPU can more efficiently check the divisor value during the execution. Since the time at which the 0 divisor will be found, which is not known in advance, then this event is similar to an interrupt. But this interrupt is internally generated, which is generated by the CPU. So our CPU will execute a certain interrupt which is produced by the CPU. So the priority of the exception is fixed by the CPU architecture because your exception is similar to your interrupt. So your exception consists of a vector table as well as the index address, everything similar to your interrupt. The vector number for an exception is usually predefined by the architecture. It is used to index into a table exception handlers. So the next one is trap. Trap is nothing but a software interrupt. It is an instruction that explicitly generates an exception condition. The most common use of trap is to enter into the supervisor mode. The entry into the supervisor mode must be controlled to maintain the security. Here the ARM provides SWI interrupt for the software interrupt. This instruction causes the CPU to enter into the supervisor mode. And ARM code is then embedded in the instruction that can be read by the handler. Thank you.